I need a heat shield. Time to play with some sheet metal tools. Okay, I don't need a heat shield. My dad needs a heat shield. It's pool season, and his pool water pump is right in the sunlight, and he thinks that's shortening the life of it, because apparently you're supposed to get more than 25 years out of those things. But I'm not going to second guess, because he bought me a big sheet of aluminum and said, I want a shield. Yes, sir. One of my dad's favorite hobbies, by the way, seems to be buying me sheet metal tools, so I think I'm going to use way more of them than is reasonable for this project. Here's what I plan to make it out of. I got a sheet of aluminum, I cut out another piece, and I got this, which was just my scrap pile. This is all aluminum. I don't really know why or where I got this from, but hey, whatever. I have a design in my head, and I'm just going to kind of wing it. I know roughly the size of the pump and where it is and how tall it is. To start with, I want to show you this. What you're seeing, if the camera can focus on it, is a big gouge created by my shears. I think it's this edge there. So if you buy these shears from like any place that sells Chinesium tools, maybe dress those edges up a bit or they'll gouge into your aluminum. I'm not bitter, maybe a little. So I'm just going to position them so that you don't see much of, whoa, what happened there? This was leaned up against a sheet of steel. Okay, so what I'm going to do is bend a flange on one side, use the shrinker to shrink the flange, which will put an arch into this. I will, of course, do that after the next thing I'm going to say. I don't know why I said that part first, which is bead roll a whole bunch of cool stuff in this to make it look pretty, even though nobody's going to see it. I did some practice on some sheet steel. I might do the pattern like that. But to get it going, I want to mark out like rounded circles, you know, with a Sharpie. The duct tape will give me a set distance from the line and from the edge. And then this on the inside here will give me a nice radius. What I want to do here is give me like a recessed panel, like the middle of it will be down just a little bit. That'll make it stronger and something or another. It really doesn't matter. This is not load bearing. I just think it looks really cool. And some crisscross lines. I'm going to use the width of the ruler as a guide. Okay, there we go. It's quite a lot of beading, but remember, I have a motor, so I can do all this work and be lazy simultaneously. This is a standard Chinesium Eastwood bead roller with their new drive system. It seems to work fine. Goes one way, goes the other way, has a speed control. Again, not sponsored by Eastwood, but I can confirm it functions. The dies are touching. There's a gap between like this lip and this lip. So there's some space in there that you can't see, but you don't want them to like right next to each other because this will slice. You want space. The metal has to go somewhere. So I make space. I crank it down until it's touching, just touching. Then I count 3 cranks to lift up the metal, put it in, double check to make sure, nope. I was trying to put that in the wrong way, the way I didn't want it to go. That would have been bad. Now I crank it down. Remember, I uncranked 3 turns. 3 turns. So had this piece of metal not been in here, there would be no stress at all. You don't need to crank the thing down. Now let's see, move this camera so it's out of my way, because I am a fantastic cameraman. And I'm going to use both hands to guide it all the way around, hopefully lining back up again so you don't see the start and stop. But no promises there. This is much, much easier than the old crank thing because you can go slow at a steady speed and use both hands to guide the metal. Suppose I could speed it up for the straight parts. Oh no, that was crazy. It was out of control. Okay, there we go. How cool is that? Look. Look at you, this side. Oh yeah, I forgot the rust. Noticing some more gouging from the edge of the dies. So it looks like I gotta dress the edges of like all my tools. Now to do these parts, we're gonna switch the dies. Now it's fitting that I'm doing something ridiculously over the top and extra cool for my dad because he is kind of ridiculously over the top and extra cool with a lot of his manly type things. He was the one who originally modified my Power Wheels Jeep when I was a little kid. Not with a steel body like I did on my Power Wheels Jeep project, but with more power. That's all. He has continued this same habit, and I have nephews that have these little toy trains. Well, they're supposed to run on 1.5 volts, but the ones at my dad's house, they now run on 3.5 volts, and they're much faster. Occasionally, one of them starts bulging its lithium battery and nearly explodes, but with all that extra fun, you need a little excitement too, right? I mean, one of the standard phrases is, what, you're trying to live forever? Like, well, it'd be nice not to die from a toy train explosion. I've noticed with these urethane ones, it helps to lube up the shaft a little bit so they slide in better. Because these suck to try to get out when they're dry. They're all, like, stuck. So everyone always inherits a lot from their parents, right? Even if they don't want to admit it. Well, I think the primary traits that I inherited from my dad were a sense of, like, mechanics, mechanical aptitude. His is, like, way through the roof. It's unbelievable. The other is my desire to make everything much more powerful and much louder. So with this, I put the ridge up relative to this depression. With this, I'm going to put the ridge down because I think that would just look better. So with this, I've counted the number of cranks to contact, but because the bottom die is urethane, it's kind of squishy, I'm going to go one extra crank for pressure and just see how it works. Oh, wrong direction. So if you're wondering, that van that I have, I got it from my dad. Why did it come with a 3-inch straight pipe side exit exhaust? My dad is why it did. You might be wondering, why isn't he doing this then? Well, he's getting a little older now. He's going to be 72, and he still works 50 hours a week. So when he gets home, he doesn't really want to do this kind of junk. He wants to go to Applebee's and have a steak. Okay, battery died while I was doing that, so you missed this part. But here, I got the things rolled in there. I think I should have done them a little farther apart and maybe a little more pressure, but you can still see the light bouncing off of it. You can see that it's gently, whatever that pattern is called. You can also probably see that it warped. Turns out I didn't pre-stretch the center part enough, I think. I think that's the problem, so we're going to have to fix that. I also rolled a flange here. I want to show you how I did that using this, this is the side, one of the side pieces. This, you'll see in a little bit. But this line needs to be a flange. It needs to be flangified for strength and stiffness. Okay, before we go on, gotta oil a couple of things. This is not turning real easy. I know, that's an oil thing. Whatever, quiet. You're not the boss of me. Yeah, they warn you that this can strip out, probably because this is cheap Chinese mild steel. And it doesn't exactly fit very good out of the box. But I'm going to keep using it, until something breaks, and then I'll fix it. But here's how I did this. So this is my little, the goop is ruining my Sharpie line. I'm going to run this through here, pulling up. And you can eventually make a 90-degree bend without using a metal brake, which is good, because my metal brake sucks. But we're going to give this a shot. I'll show you how I did this. They don't turn out good when you do it this way. Not as good as metal brake. Alright, so I'm going to roll it through. I'm making sure the line is on this side. It's running right along this edge of the die, and I'm pulling up ever so gently. Probably too gently. And then I've found right as you get to the end, there's less metal to bend. You should start pulling a little bit less. Otherwise you'll end up, at the very end, you'll have this weird crank thingy that you gotta fix with a hammer. I'm going very slow to be careful that I don't put lines all over the place. I want the line to track in the same spot every time. See, we're getting a little bend. Clean that up a little bit. And ta-da! 90-degree bend. It is, however, out of focus, but you do what you can with the tools you got, right? Now you might wonder what these are for. Well, these are holes. I want to drill some holes. I got this drill from my dad. It's an old Montgomery Ward's one that he didn't want anymore. Next up, This thing. This is called a punch and flare die. It requires a 1/2 inch hole. It falls apart easily. Put it together, put the screw, tighten it down with an impact. It punches a hole and flares the edge. Speed holes! I think I checked 18 mil. Yep, and yes, I know, silver thing does not go on impact. You need the black impact ones. Get off my back, you're not the boss of me. If it makes you feel better, this doesn't have any power and I've turned it down a little. Yet another tool that my dad gave me because he didn't want it anymore. Actually, he didn't have a compressor that could run it. Little lubrication never hurt anyone. Ta-da! At least that part of this project worked, because the tool does all of it. Cool. Okay, we have a problem. This design is very stiff and rigid. And this is bending, but this ridge ain't letting it bend. So I've tried like forcing it, and I've tried some other stuff, and nothing's working. And I've already marred the crap out of this unnecessarily. So we're going to chalk this one up to a practice panel. And I made another one. I put a little line in there. So I'm going to bend this to shape first with that. And then maybe I'll roll some beads in there so it looks purty. I don't know. We'll figure that out once I get the shape made. Maybe that's the right workflow here. Get the shape, then do the fancy beading. I don't know. I've also had a bit of a rethink. I'm just going to bend this center area here and then shape the rest of this, I don't know, somehow to make it fit. So there'll be a little extending below and above that on that piece. I can't explain it. You'll see. Needs a little more there. Bingo! Now to gently match the rest of this. Alright, so moving on. I want this to be riveted to this. Why does that suddenly not fit as well as it used to? Oh well, fits good enough. And I get to use a new toy I got. Boom! Panel clamps and clecos. Now what these do is you drill the small hole. I think this is an eighth of an inch. Use these pliers to push this. See, it extends that. You put that through the hole, the 1/8 inch hole, through the 2 pieces of metal. And let go as it pulls that in. It expands them apart and holds the panels in place. Cool, huh? I'll show you how they work. I've never actually used these before, so this will be fun. I hope they line up. Slide it through, let go, and boom! Cool! That middle one doesn't line up for crap, actually. I can see what I'm going for. It stands up, shields something under here. Gotta make some bottom here to hold it up, otherwise it's just going to fall over. And I actually took a little time break there and went and got a piece of angle, aluminum angle. This way it's stiffer than that aluminum flat bar I have over there, although I might use that in a minute here. Man, aluminum's easy to cut. I mean, compared to steel, there's no way I could cut steel this thick. Now for the bending. Cool. Bet I can sharpen that corner up a little bit. Maybe I'll ask the manufacturer of this hammer if it's wise to use it as a dolly. Hey me, can I do this? Yeah, do whatever you want. None of these faces, none of these corners are particularly good. She'll have to talk to quality control about that. Hey me, your hammer sucks. Get lost, me, or I'll hit you with it. Right in our own fingers. Now I could weld this up, but since I suck at TIG welding aluminum, I'm going to go ahead and not do that, especially because it's like, you know, it's plenty strong. There's another cleco. And now it's freestanding. Wobbly with all the crap on its way. We're back. battery died again. I think my camera battery is approaching the end of its lifespan. I'm not sure where you left off, but you probably didn't see me make this part. Yeah, it's a single strip, and I bent it around this corner, drilled some holes in it. I know that requires a lengthy build documentation process, but I just explained literally everything. It's pretty simple. Okay, so now at this point, all I have to do is disassemble this whole thing. I want to roll some cool designs in here that are a little simpler and less problematic. Then all these holes have to be drilled bigger so I can fit the aircraft rivets in there. As soon as I find where the Cleco pliers went. Tricky Cleco. Strengthening ribs. Cool. Always like a little bit of shape because it makes the light play on it or something artistic. I don't know. It looks cool. Okay, now I believe these aircraft rivets I have are 3/16. I'll just test it out here. Man, aluminum drill's easy. Oh, that's a bit tight. If I could just decode all this writing that's on the thing, I don't know what all that means. Try 13/64. Screw you, workbench. Oh yeah, perfect. Okay, we got our size. Time to start drilling some of these out. I'm leaving some of them not drilled out. That way the Clecos can still work. Alright, and for this next step, I need this. I think I need this. Yeah. This goes into an air hammer. Now you can get special air hammer things to use these aircraft rivets because these aircraft things don't take as much pressure, you know. So what I'm going to do is just turn down the regulator because I found that I usually run my regulator at 90. I'm going to run it down to like 45, cut that in half, and that seems to work for me. I don't have a bucking bar, but I do have a dolly, you know, hammer and dolly for sheet metal work. I use this thing. I use one of these side clamp things to help. Make sure it's not caught on your shirt. Stupid. Okay, I'm going to push this through. Find the dolly you just lost. That's important. There it is. I'm going to hold this up against this side protruding out while I hit this side with the air hammer. And that's going to mushroom this out so that it holds them together. Okay, aha! Drop all of your tools with reckless abandon, and boom! Aluminum rivet. Okay, and carry on, I suppose. Was that all out of focus? Good job, cameraman. I shall fire you later. That is seriously so cool. I love these things. That probably is not advisable in aircraft manufacture, that move just then. Let's see, I think that's all the holes that I had. Now time to drill some more because we don't want to use the minimum effective amount of these things. We want to use the maximum possible amount of these things. Well, there you go. A heat shield. It sits over a pump under here and blocks the sunlight from hitting it. It's also pretty stable. It's not going to get like wind or nothing, so I think that'll work. I hope my dad will be pleased. I'll clean it up a bit. And if it gets too tippy, I mean, I know from pictures of the location there's a brick on the ground, so I can just stick the brick under here and it'll sit on this flange and stop that from blowing away. There you go. One issue I notice, I'm not very good with the air hammer and sometimes I nick the rivet. See that? Really screwed that one up though. Yeah.